Hello fellow mask makers, thank you for tuning in for this video post. I'm going to try to keep this under 15 minutes, but I've got a lot of information that I need to share. I've been asked several questions and I've boiled it down to the 6 most common questions that I have been asked regarding these masks. So now, just a little bit about myself. I am a mechanical and aerospace engineer, so I've been doing this for a while. Science is my passion, engineering is my passion, and so I want to share with you guys how I'm preparing these masks and sending them out. So the questions I have been asked: why this mask? What about clear coats? What kind of seal are we using? Filters? Is PLA food safe? And sanitation. So let's start with the first one. Why this mask? So the reason why we chose this mask is because it's efficient, it prints fast, and even the original version, even though it didn't print fast, 3-hour print, the design was rock solid and amazing. The idea behind the grid to hold the filter in place and then the front grill cover was amazing. That having that extra protection against droplets is awesome. This particular design, the version 2, is nice because it's all integrated and it prints faster. Now, just letting you guys know, you have to print these hot. 225 degrees excuse me, Celsius is what we're printing at. That's because they're thinner walls and that filament needs that extra heat to fuse together. Okay, so these masks are awesome, and that's why we are using them. Okay, so now let's talk about clear coats. I've had people ask, should I clear coat these? You know, if we weren't in the middle of a crisis, I would say absolutely do so. But here's the problem with clear coats. It takes 7 to 10 days for them to dry fully. So if you have a clear coat that's been on there for 3 days and you go to sanitize it with bleach water, Lysol, or rubbing alcohol, all 3 of those are solvents. They're going to take that clear coat right off, and you're going to have a lot of noxious fumes, and then the person's going to put the mask on, and it's going to cause a lot of issues. And we don't want to make them sick, and we don't want to make things worse. So I'm telling you guys right now, please, please, please do not put a clear coat on them. Now, if some of the edges are rough and you need to sand it down or file it down, that's fine. Just make sure that you clean the mask with soapy water and get all the particulates out of it. Okay, so moving on. The next question is, what do we use as the rubber seal around here? Now, there's a couple of options. Now, for the inside, people have used windowsill. Now, I highly, highly recommend that you find ones that say closed cell PVC. The reason why is because the pores are a lot smaller and it's made of PVC, which can handle rubbing alcohol. Now, the hot glue and the adhesive can't handle the rubbing alcohol, the bleach water, so it's best when they go to sanitize these that they use an alcohol swab around the entire mask and along that window sill, that closed cell PVC window sill. Now, if you don't have that, you can go to Walmart and you're going to buy something called NexCare Waterproof Adhesive. It's kind of peach color. It's made by 3M. And I always line the nose piece with it and along here, and it works great. It's like $3 and it's pretty cheap and it sticks really well. In fact, let me see if I can find a picture real fast. Okay, here's a picture. This is another mask of another group I'm with that we've used. But this stuff right here, this works really well and it sticks. This person decided to line it like that. I just usually do it right in here. So those are the 2 best options, and this stuff can take rubbing alcohol. I've tested it. These are the 2 best options for adding comfort for the mask. Okay, so next let's talk about the filters. Alright, so here's the filter that I trust. It's made by 3M, and it's called the Filtrate brand. You want 1500 or higher. Anything lower than 1500 is not going to filter out viruses. Now, I know 1500 is considered MERV 12. However, I think on the website it says it's 13. Don't quote me on that. But it does show on the actual package that I'm looking at that it does block bacteria and viruses. So, and that is called the Advanced Allergen. Now, I prefer the 2200 because it's a higher quality and can filter out better. Okay, so a lot of the questions are, do these filters have fiberglass? The 3M Filtrate brand absolutely has zero fiberglass. There is no fiberglass whatsoever. It's actually made up of electrostatically charged spun polyethylene threads. Basically, it's just plastic. It's like cotton candy, but made of plastic. And what this does is, since it's electrostatically charged, other items that are the opposite charge, it's going to be like a magnet and they're going to get stuck to it. So that means please don't spill water on it, don't spill rubbing alcohol on it, and please do not vacuum them. Some people take them out of their furnace and want them to last longer, so they'll vacuum them, and that actually takes away the charge. So it's a great idea. It's great thinking that, okay, you could vacuum it and make it last longer. Yeah, it's a great idea, but it does ruin the electrostatic charge. Okay, so here's the thing. N95 masks are made of electrostatically charged spun polyethylene threads. Literally the same material. Now, the only difference between an N95 mask and this is an N95 masks have 4 layers. It has the 1 layer of the filtrate material. Actually, it has 2. And then it has an outer layer, kind of like a face shield. It's a hydrophobic layer that doesn't allow moisture or water to come through, so it's waterproof. And then the inside layer is the same way, but the inside layer is also coated with copper and zinc ions to help kill viruses. So, and if you're curious how that works, go look up the oligodynamic effect. That is the science and the mechanism of how metals such as mercury, zinc, copper, silver, I know I'm missing another one, actually kill viruses. So go check it out on Wikipedia. They have a great article on it. Okay, so those are the filters that I recommend. They're made by 3M and they're cheap. Cost me $22.88 for a 20 by 30 by 1 inch filter. You can get thousands of squares for these masks out of just one sheet. Okay, I wouldn't say thousands, but hundreds. So that is what I recommend. Okay. So I don't know if I said this earlier, but when printing this mask, you need to print hot, 225 degrees for the layer adhesion, all of it to hold together. So I'm just throwing that out there. You do have to print hot. These are a little bit thinner, so it's going to require that heat for the fusion. I've said so much stuff today at work and everything, I don't know who I've told what to. Okay, the last 2 things, sanitation. Actually, the last 3 things. Food grade, sanitation, and no, the last 2 things. Okay, so let's talk about is PLA food grade. The material itself, polylactic acid, has been around for years. It's been around many years, and it's absolutely food grade. In fact, most of your food packaging and water bottles are made from polylactic acid. It's literally cornstarch mixed with Lactobacillus acidophilus. If you remember what that is, that's what they put in yogurt to make it tangy. It's a bacteria. They mix that with cornstarch, and through fermentation and other processes, you get polylactic acid. Now, where it doesn't become food safe is your 3D printer. Your printing bed is nasty, the environment around it is nasty, and the color additives in the filament are nasty. So If you can get 100% pure PLA filament, that would be, and you could make a cereal bowl out of it, and that would be awesome. So yes, if you had 100% PLA, you could print something like a cereal bowl or a soup bowl, but I don't know if I would still eat out of it. You could sanitize it, which we're going to talk about next, but if it was made in a dirty environment, I don't know. That is just one of those things that I don't know about yet, personally. Anyways, so why am I telling you this? Because it's important to talk about the sanitation of these masks, because if we don't do this correctly, or at least the best we can, we don't want to spread what germs we have to the people who are on the front lines already trying to fight other bugs and viruses because they're exposed to so many people. So I'm going to show you how I set up what I call my sanitation station at home. So I print my masks. All the parts go in a box. Okay? Then in a room that's away from pets and is the cleanest room in the house, not a bathroom, I set this up on a table. 3 tubs. Now, in the first tub is hot soapy water. Second tub is just hot water. The third tub is cold water and bleach. You take 1 tablespoon of bleach per gallon of water. Now, it has to be cold water because if you use hot water, it deactivates the bleach. And the reason why we rinse, because soap also deactivates bleach. So, hot soapy water, hot water, cool to warm water in this bucket. Now, what you're going to do, it's kind of self-explanatory, but you're going to wash the part in the hot soapy water, and then you're going to rinse it in the hot water, and then you're going to put it in the bleach water to sanitize for up to about 60 seconds. And then you're going to remove it and put it on the towel and let it air dry. Then once it's completely air dry, you're going to get an unused, unopened Ziploc bag. You're going to open it and stick the mask parts in it, and you're going to Ziploc that bag, and you're never going to open it again because you don't want air to get back in. Okay, that's how I do it. Now, if I don't have bleach water, then I will remove this bucket and then have a towel, and I will use rubbing alcohol. Now, the one thing I want to say is, out of all the methods, if you can use rubbing alcohol and you have it available, please use that to sanitize over bleach water. I'm going to show you why. Here's why. In engineering and in filter creation, there's something called the wetting angle. And like, look at this drop of water. It has a wetting angle greater than 90 degrees. So what is that saying? The wetting angle is based off of surface tension. So water has a surface tension of about 72 dynes per centimeter. A dyne is an active force on, it's a unit of force acting on a mass of 1 gram. So with that in mind, bleach, which is sodium hypochlorite, has a surface tension of, I think, 73.7. So when you mix it with water, it takes it to about the same as water. So this is bleach water. Notice this pore right here. Now, PLA does have pores, but 99.9% of them are all smaller than 10 microns, which, yes, is the size of Texas compared to a virus. So notice this water is not going down into this pore because the surface tension is so high, it takes a lot of energy to break up the hydrogen bonding that's happening in the water for it to break down into here. You come over here, this is a substance, this is probably about 50% rubbing alcohol, and notice how the surface tension is less. It doesn't take a lot of energy to break up the surface tension. In fact, 70% rubbing alcohol is 23.7 dynes per centimeter, very low. And so as soon as you spray it on here, it's going to break up and flow into these pores. So there's something called the wetting test, or the wettability test. and it's a visual test, and you can try it at home. If you take a mask and dip it in bleach water or just plain water, set it on a towel, you can see how the water beads up, and then if you spray rubbing alcohol or even dip the part in rubbing alcohol, you'll see that it looks like it has a clear coat, or that it's more quote-unquote wet than the other part. And that's because the surface tension is so low, it's filling in all the pores and literally just spreading across the whole surface. So here's a cool picture that shows surface tension of different percentages. And this is 60% right here. This is 80%. And this is 100%. So look how low that surface tension is. That is why I prefer, when sanitizing, I'll do a wash, rinse, sanitize with rubbing alcohol, let it evaporate and dry. You can either swing it around in the air to get it to dry a little faster, or just let it air dry. You don't need a lot of rubbing alcohol. You can just spray it a few times on one side and then the other, and then let it air dry, and then seal it up. That is how I do my prep, and that's how the sanitation works with PLA. That is probably the best method. Now, this picture actually came from a person that I know who's a physicist, and his job is to make filters that filter out viruses from people's blood, and they are required by law to use 70% or higher rubbing alcohol. And their filters are like 0.001 microns, like very, very small with pores. So if 70% rubbing alcohol is good enough for them, it's good enough for us. So with that in mind, those are the questions that I've been asked, and these are just my recommendations to you guys to try to follow. And I just want to thank all you guys for all your help that you've been doing and everything that you contribute to the group. So thank you for watching, and have a great night.